guys, one of the hardest things to find for your RC tractor or any vehicle you want to build is a drive motor, and the reason is that most of the motors you find on eBay and other websites like that, motors that are reasonably priced, are intended for other applications. They might have come out of a printer or a part of a car or something, so they're most likely motors that were designed for a specific application. This example here, these motors are brilliant for our applications. They make fantastic motors for screw mechanisms because they have this great little gearbox, but that's not what they were intended for. I have no idea what this was intended for, but it was surely some industrial application. Now, for this reason, I thought I'd do a little video of some of the little motors that you can get on eBay, some of the cheaper ones, and we'd see if they were good and what we might use them for. So just before we get started, you can get motors out of lots of different things. Like these motors here, they would have come out of an old car radio. They're small and they're flat, so they've been designed to fit into that narrow space of the radio. There's other different things here. I have motors here that came out of DVD players. As you've seen in my my Marston grain trailer, I was using a motor and a gear mechanism from a DVD player for that, and there's lots of different things, but they're clearly designed for different applications. They're very big. Here's another very big one. This is a 9-volt motor, and it has a gearbox in it. But this is an extremely strong motor. This actually comes out of a beacon off a tractor or a digger. That's a very strong motor. It's it's an industrial motor. But there's different types of motors. Like these are brushed DC motors. So you just give them a DC voltage and away they go. That's no problem. Then you have these type of motors here. I got these on eBay. These are stepper motors, and you see there's 5 wires here. So you need to pulse. In this case, it has 4 coils inside it. So you need to pulse the coils to move the motor around. And this one has also been geared down. So this is also a very strong motor, but you need to pulse that and take a lot of power to do that. So that's not much use for our RC tractors. You wouldn't really need stepper motors for that. Just a simple DC motor. But normally the motors that you salvage, they don't come with the gears built into them. Normally they're just like these motors, where they have a little plastic gear on the end, and the gearbox is somehow built into the device. Here's a servo motor. And the gears are inside the servo house and they're not inside the motor, so that's just a simple motor. And if you tried to run your RC tractor directly from one of these, it would be too fast, and that's assuming that it was actually able to push the weight of the tractor, which it probably wouldn't be, but because there wouldn't be that much torque. Whereas a geared motor like this one from eBay would be ideal. It would have a huge amount of torque, so the little motor would be spinning very, very quickly. It wouldn't have much torque, but after that's been converted through the gearbox, you'll have a lot of torque on this output shaft. So they're brilliant little motors. So these are the motors we're going to have a look at today. All of these ones, they cost less than $4, I think. They're pretty cheap. These ones are a bit more expensive, but they're a lot better. So there's a reason why these are more expensive. They have metal gears. They're very small. It's pretty much ideal for our application. But I ordered an array of different motors from eBay, the cheapest we could get, because don't forget that the Seeker motors are great, but you need to pay about roughly €20 to buy the motor, and from vendors I've seen, it's been about 10 to €20 then to ship it. Well, to ship it to Ireland anyway. So that's why I look for alternatives. But if you can afford the Seeker motors, they are brilliant. But you might want to buy them, like you might want to buy 5 or 6 of them at once to kind of counteract the cost of the shipping. So we're going to have a look through these different motors as possible alternatives. Okay, so the first motor we're going to have a look at is this little, looks like a hobby motor, a toy motor, and it has 3 little plastic gears in a gearbox here, but they're pretty big. Okay, so we would assume that this is aimed at maybe a hobby robot. You could easily make a robot with that. Thing to note about this one is that hex shaft there, that is the same as a Thalia shaft. So this would be compatible with Thalia parts. So this one costs $360. It has a little on off switch, which is useful, I suppose. But it's rather bulky. I mean, look at all the space that's wasted around here. Well, I don't know if it's wasted. I mean, they're trying to keep the cost down, and to keep the cost down they need big gears, and you kind of need space for those big gears. So it seems alright. I mean, for if you had maybe a combine harvester or something that you wanted to convert to RC, maybe it would work for that. The gears seem reasonable enough. I mean, if you were going to put huge stress on them, they'd probably break. But you know, unless you're going to try and push something with your combine harvester, you'll probably be okay with this motor. You know, you want something big enough to hide this motor anyway, because it is quite large. If we turn up the voltage here, so there we go. We're trying 0.3 of a volt, and our motor is already spinning. Now, the eBay seller didn't give me a voltage. There's nothing indicated on the page I bought this from, but given the little motor, we can assume that around about 3 volts is probably a reasonable voltage to be using this motor at. So if we up the voltage, so there's 1 volt, and we'll try and lower it down. Okay, so we don't have a huge amount of torque, but still that's a reasonable amount for a small motor. I mean, you should you know, if you were doing this in a combine, you're not going to be loading it down as much as I am pushing it here. I don't think it should be reasonably a reasonably light load with your combine harvester. So let's up it to 3 volts and see what it's like then. Okay, so at 3 volts we seem to have plenty of torque. It's quite hard to stop the shaft now. So when we upped it to 3 volts we had plenty of torque, although you know, if your combine harvester was going that fast, I think it would be pretty hard to control. That the gearbox doesn't slow the output speed of the shaft by very much. It seems pretty fast. So maybe this motor is better suited to like an RC car or something in 1/16 scale, something like that. But it seems like a reasonable motor. The gears seem reasonably strong. The output shaft compatible with a Thalia. That's a good point. And other than the size, I'd say it's a pretty good motor. It's reasonable. Okay, so here's our second motor. This one cost $1.90, and it is labelled as a motor for an Arduino robot. So we can probably assume that this motor is going to be reasonably strong, because you know, the robot could be carrying quite a bit of weight in servos and other electronics. So we can probably assume this motor is going to be quite strong. In this case, the seller does give a voltage that says it can work from anywhere from 3 volts to 12 volts and recommends 6 volts. So the reason for that would be the lower voltage you operate your motor at, the longer it's going to last for. So let's just turn up the voltage here and see at what voltage it starts to move. Okay, so in this case the motor didn't start moving until we reached 1.9 volts. So let's keep going, we'll go to 3 volts. Okay, so there's around about 3 volts. It stops pretty easily at 3 volts, it's not too bad. We'll keep going, we'll go to 6 volts. Okay, so at 6 volts our output shaft is probably going a reasonable speed for an RC tractor, and it's getting quite difficult to stop. So the only downside is that it's rather big, this motor, so it's probably better suited to a 1/16 scale model really. But maybe you could find a place. This might be better for a combine model than this motor we looked at earlier. It does seem to be a lot stronger, and we can keep going up to 12 volts. So let's see how fast it's going at 12 volts. So at 12 volts the motor's going pretty quick, and it is very, very difficult to stop that motor at 12 volts. So probably good for a combine model or a pretty large model, and although you mightn't want to go to 12 volts, it's still a pretty good motor at 6 volts. I think it'd be pretty good for a combine model. So that's the second motor we've seen that's probably a good choice for combine model. And remember, this was only $190, so it's pretty cheap. That includes the shipping, so pretty ideal. So here's another very cheap motor. This one was $3, and it just consists of a couple of gears on a little frame with another hobby motor on it, a little DC motor. And this one, if you can see, the frame has lots of little holes, so you can change the gear ratio, and it's just the little shafts are just held in with little rubber end stops, which seems to work pretty good. So let's crack this one up and see how it goes. It should be able to operate at 3 or 4 or 3 or 6 volts according to the eBay page. So let's see from what voltage it starts at. So around about 1 volt. It sounds a bit rougher than the other motors did. Let's go to 3 volts. Alright, let's try it at 6 volts. So at 6 volts we were slowing it down there. It was taking about an amp to do it. It It's okay. It's not the best built motor, and it makes a lot of noise because it's not very well built. But you can change the gears, which is a nice little feature. But still, it's more for prototyping something. So say you're prototyping a little car or something, you might use this and change the gear ratio until you got a gear that suited your model. I'd say that's more what this is designed for. But it's a little bit like a Lego set with the way you can just slot the shafts in, and you can choose the position of this this block. So probably not very well suited for our application, but I'm sure you could find some use for it. I mean, if you had a diorama or something, you could surely employ it in that some way. This one was $3, so I don't know. I think this one was much better value for money. This is a little bit too rustic, a little bit too simple. So I'd say buy this one rather than this one. One thing about this motor, I ordered this little bag of gears a while back. They were I think about $5 for just a set of different little gears, and I just checked there, and the gears of this motor mate with this this little gear set. So maybe you could find a use for that. I mean, you have things like this this long kind of rack gear, so you could maybe use this motor to drive that in some way if you had some application for that. Or there's a world of little little gears like this, so you could gear this motor up considerably if you had you'd need a couple more of these little shafts, but you could gear the motor up a lot and probably get a pretty strong motor as a result, and it'd be exactly the gear ratio that you wanted. So from the perspective of being able to modify it, you know, that is the most modifiable gearbox, I suppose you could call it. But that's kind of all that it has going for it. I mean, these other gearboxes just seem so much stronger, and this, because there's no second one of these blocks on this side, you know, the shafts aren't perfect. You know, they're a little bit loose. That's probably why it's so noisy. But yeah, that's a possibility if you're interested in this, that you might be able to buy this extra set of gears and make exactly the gearbox you want. This is a tiny little Planetary gear motor. It's even smaller than our gear motor we use for the screw mechanism, and this one was a bit more expensive. It was $4.60. I'm not sure what it's from. It might be from a camera or something. It's very small, much smaller than any of the other motors we've looked at. So it has to be from something that would require a very small motor. So probably some sort of handheld device, but I have no idea really. So this one's supposed to be good to from 3 to 6 volts, and it starts moving at around about 0.9 volts. Let's go up to 3 volts. So there's 3 volts. It's a lot slower. It's quite hard to keep the wires on this. So even at 3 volts it has quite a bit of torque. When we installed that last motor it went to nearly an amp. This one is only a couple of milliamps really. So let's go up to 6 volts. That is a pretty good motor. At 6 volts we seem to have plenty of torque. The only thing is this little connection here. I'm not 100% certain how we could get a good connection from that to a wheel of our tractor or whatever it is we want to connect to. it looks like a Lego connection, so maybe a Lego connection would fit to it. So I just grabbed a piece of Lego there. If we push it in, it's a little bit loose, so it's not going to stay connected to it or anything. So if you had it in the Lego set, you could, you know, if you could connect it in a way that this was up against the face, it would work fine. But for our application, it's not exactly perfect. The tractor I was thinking of using this motor in was the Ford 7810, because you know, it's a very small model, so I need a motor that can fit into this small space. So I'm thinking I might be able to get a motor in here. I'd have to drill away all these parts here, but then I might be able to fit the motor in and get some drive from this model, which is pretty difficult because all these other motors are kind of too big. But yeah, we might see does this motor work, and that might be a possible application for it. So the last motors to look at are these small gear motors. You've seen this one before in the cramp half pipe trailer. It worked pretty good in the screw mechanism. This one I intend to use in my tracked John Deere model. So I have two of these. These ones are, you know, in this slightly different configuration, so they actually cost quite a bit more. These ones were $11.50 each. So I have two of these for that model. They were pretty expensive for this job, but these other ones are $4.15 and they're a lot easier to get. I think there was only 2 or 3 sellers on eBay selling these, whereas there's loads of people selling these ones. So they're supposed to be good to 6 volts. So let's see what voltage they start moving at. So there we go. At 1.2 volts, our motor starts to move, and we can stop that. That's very hard to stop that motor moving there. So we're at 3 volts now, and no, I couldn't stop that. This motor is actually slower than this motor is slower than the one in the half pipe trailer. They were actually a lot faster than this. So I'll just up the voltage to 6 volts. There's 6 volts, and you can see that's still pretty slow. That is next to impossible to stop. That's a very strong motor, and at only €4, that's a good buy. So I'd advise these motors. The speed of that though, that's a 30 RPM motor, this one, so it's actually pretty slow. You can get them in 60 RPM as well, so maybe that's a better motor, maybe, because you know, you'll be waiting a long time on this to screw the screw mechanism from the half pipe trailer. It'll be pretty slow, that one, whereas this one should be the same. This should be 30 RPM as well. So we'll just check. This should be pretty ideal for the tracked John Deere, because it's such a strong little motor. So let's see. Yeah, there's no way, no matter what you try to pull with the John Deere, it's either going to pull it or it's going to break the wheels. Because that is extremely powerful. And it's extremely powerful, and I'm not even seeing a blip on the current when we try to slow it down. So, you know, we're talking tens of milliamps when I was loading down that motor, which is pretty ideal for our applications. We don't want a huge current. You've seen in my previous video with the tracked John Deere that I was getting massive current when I tried to move the John Deere model. That shouldn't be a problem with this, because there's just such a huge amount of torque that the model should be able to pull pretty much anything. So make sure and subscribe if you want to see that video, because that should be coming up soon enough. I intend to get working on that pretty shortly. I have little adapters to connect this shaft to the shaft for the Thalia wheels, and yeah, it should be up pretty soon. In the next couple of weeks anyway, you should see me at least testing the motors in the John Deere. Mightn't be the full model, but it'll be me testing this drive system, because I think this is going to be the one that works best with it. So if you liked the video, give it a thumbs up, and if you have any questions, either post them here or in the forum. And like I said, there'll be the John Deere build coming up, and I'll probably have the Ford build as well when I try to stick the smaller motors into the Ford. That might end up just ruining the model, but we'll see. So make sure and subscribe so you don't miss out on those. And that's everything I have for today, so thanks very much for watching.